Welcome. Today we're diving into how Snowflake efficiently stores and retrieves your data using partitioning and micro-partitioning. This is crucial for understanding Snowflake's performance and cost effectiveness. By the end of this video, you'll understand how Snowflake automatically manages your data behind the scenes. Snowflake's data storage architecture emphasizes scalability, performance, and efficiency through innovative partitioning strategies. Snowflake stores data via micro-partitions and optimizes queries through pruning. Micro-partitions are the fundamental units of storage in Snowflake. They form the building blocks of how data is organized and stored within the platform. Unlike traditional databases where you must manually define and manage partitions, Snowflake handles this automatically. This removes the complexity and potential errors that come with manual partitioning schemes. Snowflake automatically creates these micro-partitions as immutable and compressed units of data. Being immutable means the data within them cannot be changed once created, ensuring data integrity and consistency. Each micro-partition typically ranges from 50 to 500 megabytes in size and contains a subset of rows from your table. The data is organized in a columnar format, which optimizes storage efficiency and query performance. These micro-partitions are automatically created whenever data is ingested into Snowflake, whether through bulk loads, streaming, or other data ingestion methods. This seamless process happens behind the scenes without user intervention. While Snowflake handles the partitioning, you can influence how data is organized within micro-partitions using clustering keys. By specifying one or more columns as clustering keys, you tell Snowflake to group similar data together. For example, using a date column as a clustering key will group data with similar dates into the same micro-partitions, leading to faster queries when filtering by date. Without keys, Snowflake uses natural ordering based on ingestion. In the storage layer of Snowflake's architecture, micro-partitions hold the data, and here's where the magic happens. Pruning. When you run a query, Snowflake's Query Optimizer examines the metadata of each micro-partition, including minimum and maximum values for each column. It then identifies and reads only the partitions that contain relevant data for your query. This partition pruning can eliminate 90 to 99% of unnecessary data scans, significantly reducing compute costs and improving performance. For instance, a query filtering by year 2024 might prune partitions outside that range. Snowflake stores data in its cloud storage, such as AWS S3 or Azure Blob, with micro-partitions replicated for redundancy. Micro-partitions are replicated for redundancy to ensure data availability and durability. Compression algorithms like Snappy and ZSTD, combined with a columnar format similar to Parquet, ensure storage efficiency. Pruning works at the partition level, not row level, making it complementary to other optimizations like result caching. This supports Snowflake's multi-cluster shared data architecture, where compute virtual warehouses are separated from storage. Snowflake introduced intelligent clustering in late 2024, using machine learning to automatically adjust clustering keys based on how data is queried. This machine learning approach analyzes query patterns to dynamically optimize data layout without manual intervention. The result is significantly improved performance, with claims of up to 50% faster queries for complex workloads, while reducing the need for manual tuning. This feature is now standard in enterprise and higher tiers, enhancing the automatic clustering introduced in 2023. Snowflake's ML models continuously analyze historical query data to suggest optimal clustering keys, reducing latency by 30 to 40% overall. Real-world applications highlight micro-partitioning's impact on performance and cost savings. A major retailer analyzed 10 terabytes of sales data daily. By setting clustering keys on store ID and date, they achieved 80% faster reports. Partition pruning reduced compute costs by 60%, enabling real-time inventory insights during peak seasons. A healthcare provider migrated from on-premises systems to Snowflake, leveraging micro-partitions for protected health information compliance. Clustering by patient ID and diagnosis codes allowed efficient pruning in GDPR-compliant queries. This cut data scan times from hours to minutes, with 70% cost savings and improved patient outcome analytics. A bank processed 500 terabytes of transaction data using automatic clustering, Pruning isolated fraudulent patterns in seconds, preventing significant losses. According to reports, this reduced false positives by 50% compared to traditional warehouses. These examples demonstrate that micro-partitions handle petabyte-scale data without requiring manual partitioning schemes, unlike legacy systems that need sharding. Experts praise Snowflake's partitioning for its simplicity and efficiency. Snowflake CTO calls micro-partitions the secret sauce for elasticity. Trends indicate increasing use of AI for predictive clustering, integration with data lakes and streaming, and a focus on sustainability and cost efficiency. The future leans toward more intelligent, adaptive systems, positioning Snowflake as a leader in autonomous data platforms.